Hello everyone. This video will provide the background you need for our next homework assignment, which is to build a simple web crawler, get some text from the web, and process it. We'll get to the homework later in the video. First, let's talk about web pages. Web pages are coded up in HTML, hypertext markup language. There are many markup languages. XML is used to handle structured data, and there are packages in Python to help you read XML if you ever need to. But the markup language of the web is HTML. Here's a really simple example of HTML in the corresponding web page. If you just type this into a simple text editor and save it as a .html, and then open it in a web browser, you'll see the rendered HTML on the web page. HTML markup is typically in pairs of tags enclosed in angle brackets. Tags aren't case sensitive, but lowercase tags are more typically used than uppercase for HTML. Any tag that starts with the exclamation point is a comment. This first line of code here is a comment, and it tells browsers that this is an HTML document. All of the HTML needs to be within the opening HTML bracket and the closing. So notice they're identical. They both have HTML enclosed in the angle brackets. The closing bracket has this slash. The part of the web page that's visible is within body tags. Heading tags, the H1, here's the start and here's the end for H1, they give you bigger headings. And then as you go from H1 all the way down to H6, you'll get smaller and smaller headings. Paragraph tags are typically used for blocks of text. Any white space that you choose to put into the HTML is ignored, but it can make your HTML more readable. And here I have an example of an ordered list, the start and the stop. And then the li tags are for each item in the ordered list. If I wanted to make it an unordered list, I just change these to U, save it and refresh it, and we see now they're bulleted items. Here I've added the optional heading tags and used it for title tags. This title now appears at the top here in the tab. People also use this space to include meta tags for keywords, as well as links to style sheets. So notice there's absolutely no formatting here at all. You can put formatting within tags, but that's not the recommended practice, because if you want to change your formatting later, you'd have to change it in all of those tags. The formatting is usually specified in a separate file called a CSS or cascading style sheet, and that controls the appearance of all of the HTML elements. The advantage of the CSS is that you can change your formatting in one place and have that cascade to all of the pages in your website. As an example, I'll look at my web page here, UTD. If you right-click on most web pages and go to View Page Source, you'll see all the HTML for that page. What I did for my website at UTD is I just downloaded a template, and you can see here within the heading, I have the link to the cascading style sheet that I used. And then if we look at that cascading style sheet, you can see for each type of item, for example, the body, it's going to specify font, colors, and things like that. The cascading style sheets are just about the look of the web page, and we're not going to be interested in that. So I'll leave you on your own to explore that if you're interested in learning more about it. Other kinds of tags are image tags, which may look like this. First, we have a relative path to the image file. Then you can optionally specify its size. And the alt text is good for visually impaired. Some HTML readers for the visually impaired will read that text, since the visually impaired person may not be able to see the picture. Link tags look like this. They start with the A, the anchor tag. The The link text is what's actually displayed to the user, and then the href within quotes has the actual page. Notice I included a closing slash. Some web browsers automatically add that, but some will not, which causes two requests to the server. You can create tables with HTML, enclosing them in table tags. TR specifies what's on a row. TD is for data items, so those are more or less like columns within a row. And if you want headings, you use TH. Rendering that into the web page, you can see that this is not formatted very nicely. So this is definitely a case where we'd want to use cascading style sheets. Most of the tags that you see are basic HTML tags. Other tags you'll see are script tags for JavaScript, meta tags, and you'll see div a lot, which is just a way to group items together. We've seen how to create a web page. A website is just a collection of web pages and other files that share a common domain name. A web server is a computer that receives requests for a web page from a browser and returns the content of the web page. This works through a client-server system. The web browser is the client that makes requests from the web server. Clients and servers communicate through a protocol, HTTP, Hypertext Transfer Protocol. Any transmission of information on the internet is done through another protocol, TCP/IP, Transmission Control Protocol and Internet Protocol, and that packages content for transmission and makes sure it arrives. A server will send web page information in chunks called packets using the TCP/IP protocol. A web browser then collects these packets and displays the web page. The HTTP protocol handles different types of requests and responses between clients and servers. Some of these are GET, which is a request data from a resource. Some is POST, to create or update a resource. Another is PUT, which is similar to POST but will not create multiple resources. And DELETE, to delete a resource. When a web browser wants to display a web page, the domain name is translated to an IP address through the DNS domain name system. DNS servers provide lookups of IP addresses for websites. When you connect to the internet, you'll have a unique IP address. A common standard for IP addresses is IP4, which looks like 4 numbers separated by dots, where each number can be from 0 to 255 decimal. So this could be an IPv4 address. IPv4 addresses are 32 bits, which allows for about 4 billion unique addresses. With the growth of the internet worldwide, more addresses are needed, and so a new protocol, IPv6, is being used. IPv6 is 128 bits, written in hex with each group of digits separated by colons. So this could be an IPv6 address. An HTTP request will return content if possible, but other conditions will return a status code. Here are some common status codes that indicate that something went wrong with the request. So this is a very high-level view of communication between web browsers and web servers, with just enough information that we need to understand web scraping. These terms have a bit of overlap. When we talk about web crawling, we're talking about gathering the links between pages, the web part of the web. When we talk about web scraping, we're talking about grabbing data from websites. A common misconception about content on the web is that if it's on the web, it's free content. Legally, the content provider owns the content and has the right to determine how that content can be used by others. When scraping data from a site, make sure to read that site's terms and conditions. Many sites do not allow others to use the data for commercial purposes. Limiting the rate at which you are scraping a website can prevent access issues, as well as prevent you from getting blocked from the site. Scraping during off-peak hours can limit the impact of your crawler as well. Before scraping a particular website, check if they have provided an API. Many popular websites such as Twitter and Wikipedia provide APIs to enable people to scrape data safely. Many sites have a robots.txt file that specifies how a site should be crawled or indexed for search engines. The file can be found in the root directory. The information in a robots.txt file can be hard to interpret, but here's an example to get started. This simple example has a rule for Google's web crawler specified in the user agent field. The disallow field says that Google shouldn't crawl in the no Googlebot directory or any subdirectories. The second rule has asterisk for user agent, meaning everyone else. The allow field has just the root, so that means that all directories can be crawled. In contrast, a disallow would mean that you can't access anything. This notebook, which is in the GitHub, will show you a simple way to download text from the web using Python's urllib. And I have documentation for that here. First, from the urllib, we import request. Here I'm specifying the URL I'm interested in as a simple text string. Then using request.urlopen, I open that up, read it and decode it, and then print it out. The second example has a different URL, and notice that when we print it out, we've got all the HTML in there. So this is not really a good approach for scraping information off most web pages. We'll look at a different method. There are a lot of different Python packages that will help you with web scraping. In this notebook, web scraping here, I'm going to use Beautiful Soup. And I have a link here on how to install that. Notice I'm still using urllib to handle the URLs, but I'm also importing Beautiful Soup. I'm starting with a URL to a New York Times article, open it and read it, and then I make a Beautiful Soup object out of what I read in. This code will kill all the script and style elements, and this code right here will extract just the text. Printing out the first part of that text, we see that it looks pretty clean, but still needs some work. So then you can just do regular things like regular expressions to get rid of white space, and so forth. Another thing that's useful is to just extract the paragraph tags, since that's where most of the interesting text will be. And so I've done that here. From the soup object, I've just selected only tags P and then iterated over those. When we want to build a web crawler, we're going to want to extract the links from the anchor tags. So we're going to find all of the A tags and then print the href here. This third notebook shows you a web crawler, almost. It's not quite a web crawler. What I'm demonstrating is how to extract URLs off a web page. This bulleted list here gives you some hints about how you might go from extracting links to actually having a web crawler. So you could start off with a queue which just has a starter URL, or you could have more than one starter URL in it. And then for each link in that queue, go to that page, extract all of the URLs, and add them to the end of your queue, and then just keep going. So this could go on forever. You may have to put some code in there to stop it after you've gotten a certain number of links. That's the basic idea of a web crawler. So what we've got here is, again, using Beautiful Soup, and I have a starter URL here of a Wikipedia page about Vince Gilligan. My family we were fans of Breaking Bad, and we're fans of Better Call Saul as well. So I make my request, showing slightly different code here than we've used before. I make my request and make a Beautiful Soup object out of this first page. And then I'm going to write all of the URLs that I've extracted here out to a file. And here we see we didn't get off of Wiki very much. And also we see a lot of junk in here that we're not really interested in. So here I'm just putting in some extra code to see if it's relevant to Vince Gilligan. These hashtags are links within a page. You may choose to ignore those as well. And I wrote all the URLs that I found out to a text file. So let's read it back in and see what we got. Again, a lot of these are Wikipedia, but we did get a little bit out of Wikipedia with different sites as well. In this notebook in the GitHub, I show a little bit different way to go about it here. Just extracting some text, and we see that it's quite a mess. And that's going to be the case most of the time when you extract text from the web, from a web page. It's going to be a little bit messy like this. So in the homework, one of your tasks is going to be to find some important terms out of all of the documents you collect from the web. And we'll get into the homework instructions in a minute. One way you could do that is with simple term frequency. Term frequency has limitations. It's not the best metric for finding important terms. Something that's slightly better is something called TF-IDF, which is term frequency multiplied by inverse document frequency. And multiplying it by the inverse document frequency can kind of tease out which of those terms are actually important. And you don't have to use TF-IDF. Just want to point out that in this section, part 4, on information extraction, I have an example notebook where I go through the process of looking through 4 different texts, using those as my 4 documents, and finding TF-IDF, in other words, finding important terms. So one of these documents is a chapter of anatomy, one is business law, one's economics, and one's geography. And I won't go through the steps here. The first step, of course, is to calculate term frequency. That's half of the equation. The second step is to calculate inverse document frequency. And then you put those together, so I get a TF-IDF dictionary for each document. All right, so for anatomy, for this particular chapter, these were the important terms. We see for business law, these were the important terms, economics, and geography. So you see that TF-IDF did a really good job of identifying important words. And again, in this notebook, I'm going through this manually, and we'll get to this later in the course. And the point of going through it manually is so that you understand how TF-IDF really works. There are packages out there that will help you calculate TF-IDF if you want to. The big picture of the homework is programmatically find at least 40 terms that seem to be important according to whatever metric you're going to use. And then you could manually go through and figure out which 15 topics are going to be important to you. So why are we doing all this? Stepping back, the big picture for a later homework assignment, not this homework assignment, is that we're going to use information that we've gleaned off of the web through our web crawler and web scraping and text preprocessing. We're going to use that information to be the foundation for a chatbot. Okay, we'll talk about chatbot later, but the point of this assignment is to do the web scraping, do the preprocessing, find important terms, and then build some kind of knowledge base of sentences based on each topic. So that would give a chatbot something to talk about. And another thing I want you to think about is think about what you would want your chatbot to talk about. And so I just made up a really goofy kind of sample initial dialogue here, another one, and again we're going to do the chatbot part later, but I do want you to be thinking ahead about what kind of information you want to gather for the later project of the chatbot. After all of that background information, we're ready to talk about the instructions for Homework 5. Homework 5 is going to be worth 200 points, so you're going to want to spend a lot of time on this. For this project, you can work alone if that's easier for you, or you can partner with one other person. Just one of you, if you have a partner, just one of you would need to upload everything being your code, all of your output files, everything all zipped together. So our objective here is to create a knowledge base scraped from the web. And again, as I mentioned earlier, we're going to be using this knowledge base later in a later homework to create a chatbot. But for this homework, this is what you need to do. You're going to need to build a web crawler, starting with a starting URL representing some topic that's of interest to you. A sport, your favorite film, a celebrity, a political issue, whatever is interesting to you. And then from that, output at least 15 relevant URLs. Try to make sure that some of those URLs, those starting URLs, are outside the original domain. Then write a function to loop through your URLs and scrape off the text from each page. So I want you to store each page text in its separate file. Then write a function to clean up the text. Basic starting things are deleting new lines and tabs. You could extract sentences. And then your 15 input files are just the raw stuff that you got from the web, and your 15 output files will be the cleaned up text. And feel free to have more files. This is just a minimum. Then write a function to extract at least 25 important terms. You could use term frequency, TF-IDF. It's a good idea whenever you're doing any of these measures is to first lowercase and remove stop words and punctuation. Print out your first 25 to 40 terms, and then manually, meaning like just sitting down and thinking about it, pick 10 terms at least based on your interest and your knowledge of that domain. So step 6 is build a searchable knowledge base of facts that a chatbot, again that part's later, can talk about. The term knowledge base is very vague and very broad. It could be as simple as a Python dictionary, which you can pickle. But if you do something more sophisticated, like a SQL database, that would be worth some extra points. I also want you to have a document that gives some description about how you created your knowledge base, include some screenshots of it, tell us what your top 10 terms are, and write up a couple of sample dialogues like I did about how you would like to interact with your chatbot based on your knowledge base. And I will say you're not boxed into anything that you create here. If when we get to the later homework of building a chatbot, if you want to change things that you did from the first homework, that's perfectly fine. These are what the different steps are worth, so you can see that the web crawler and the knowledge base are worth the most points. And I do hope to find a time and a platform that will let you guys share what you learned in your chatbot projects with each other. That's the overview of the homework and what's going on. I want you to start this as soon as possible because it is worth more points. This is not something you want to wait till the last minute to work on. In terms of finding a partner, I'm not sure how that will work given that we're all locked down in our different locations. But you may be lucky and have someone you know in the class, or feel free to post out on Piazza that if you're looking for a partner. And post your other questions there as well. This is a substantial project that you can really sink your teeth into, and it's used a lot of what we've learned so far about Python and NLP and stretches that a little bit. So I think you'll enjoy it.